Close your eyes. Imagine the Earth 250 million years ago. No cities, no borders, no human voices. Only wind over a vast inland sea. The sun burns relentlessly. Water begins to disappear. An ocean shrinks, not violently, but patiently. Day after day, year after year, century after century. Water evaporates. What remains behind is not emptiness. It is memory. It is crystal. It is salt. Long before oil fields, before gold mines, before industrial revolutions, there was a mineral that quietly controlled survival. Salt preserved food. Salt built trade routes. Salt funded empires. Salt trapped petroleum. Salt shaped landscapes. Salt flows beneath your feet even now. And inside your veins, ancient seawater still whispers its chemistry. This is the story of sodium chloride. This is the geological biography of halite. This is the story of how oceans turned to stone, and how stone built civilization. Salt is chemically simple. NaCl, sodium chloride. But its simplicity hides a cosmic origin. Sodium was forged in ancient stars. Chlorine was born from nuclear processes in massive stellar explosions. When those stars died, their elements scattered into space, eventually forming our planet. On early Earth, volcanic gases and mineral weathering released ions into primitive oceans. Rivers carried dissolved sodium and chloride from eroding rocks. Over millions of years, oceans became salty. Today, seawater contains about 35 grams of dissolved salts per liter, most of it sodium and chloride ions. But how does dissolved salt become rock? The answer lies in evaporation. When seawater is trapped in a restricted basin, cut off partially from open ocean circulation, evaporation begins to concentrate dissolved minerals. Minerals precipitate in a predictable order. Carbonates, like calcite. Gypsum, CaSO times 2HO. Anhydrite, CaSO. Halite, NaCl. Potash salts, like sylvite. Halite forms only after about 90% of the water has evaporated. Imagine the scale. To create a 1-meter thick salt layer requires approximately 75 meters of seawater. Some ancient basins contain salt deposits over 1,000 meters thick. That means entire oceans evaporated repeatedly. One of the most dramatic examples occurred during the Messinian Salinity Crisis beneath what is now the Mediterranean Sea. Around 5.6 million years ago, tectonic shifts restricted its connection to the Atlantic Ocean. Evaporation exceeded inflow. The sea nearly dried out. Massive salt deposits, thousands of meters thick, formed on the seafloor. When Atlantic waters finally refilled the basin, the salt remained, buried, preserved, waiting. Salt is the fossil of climate. Most rocks fracture under pressure. Salt flows. At depths of more than 500 meters, salt behaves plastically. Under immense overburden pressure, it deforms slowly like cold honey. This unique behavior creates one of geology's most extraordinary structures: salt domes. When buried beneath denser sediments, salt begins to rise because it is less dense and more ductile. It pierces through overlying rock layers, forming vertical columns that can extend kilometers upward. These structures are common beneath the coastal regions of the Gulf of Mexico. Salt domes distort surrounding rock layers, creating structural traps. And in those traps, oil accumulates. Hydrocarbons form from organic matter buried in sedimentary basins. As temperature and pressure increase, oil and gas migrate upward through porous rock. But when they encounter impermeable salt, they cannot pass through. Salt acts as a seal. Without salt structures, many major oil fields would not exist. Entire energy economies, offshore drilling platforms, refineries, pipelines, owe their existence partly to ancient evaporated seas. Salt shaped the petroleum age. Before fossil fuels, salt was power. It preserved meat, fish, vegetables, allowing storage beyond seasonal harvests. In the Roman Empire, salt roads called Via Salaria transported this vital resource. Some historians link the Latin word salarium to salt allowances given to soldiers. Across the Sahara, camel caravans transported salt slabs from desert mines to trade hubs like Timbuktu, exchanging them for gold and goods. In China, state control over salt production funded dynasties for centuries. In France, the Gabelle salt tax fueled resentment that helped spark revolution. Salt determined trade routes. Salt influenced politics. Salt sparked wars. It was once worth its weight in gold. Human blood plasma contains roughly 0.9% sodium chloride. This concentration is critical. Too little sodium, nerves misfire. Too much, cells dehydrate. Sodium ions enable electrical signaling in neurons. Chloride ions help regulate acid-base balance. The chemical balance of your body mirrors ancient seawater. Life began in the ocean. When vertebrates evolved to live on land, they carried the ocean inside them. Salt is not foreign to us. It is ancestral. Modern salt extraction uses three main methods. 1. Underground rock salt mining. Massive tunnels are carved into ancient evaporite layers. Machines grind and transport crystalline halite. One extraordinary example lies beneath the Polish city of Wieliczka, where miners carved chapels, chandeliers, and entire cathedrals from salt rock. 2. Solution mining. Water is injected underground to dissolve salt. The brine is pumped back to the surface and evaporated. 3. Solar evaporation. Seawater is channeled into shallow ponds and left to evaporate naturally. Today, salt is essential for chlorine production, caustic soda manufacturing, PVC plastics, de-icing roads, water softening, glass production, chemical synthesis. Salt underpins modern industry. Salt dissolves easily in water. Groundwater can carve caverns in underground salt beds. When ceilings collapse, sinkholes form suddenly. Around the shrinking shores of the Dead Sea, hundreds of sinkholes have opened as water chemistry shifts. Entire roads and buildings have vanished overnight. Salt landscapes can be unstable. The same mineral that preserves life can erase infrastructure. Thick evaporite sequences reveal arid climates, restricted marine basins, high evaporation rates, tectonic isolation. Geologists study salt layers to reconstruct supercontinents like Pangaea and understand plate movements. Salt tells the story of vanished seas and ancient atmospheric conditions. It is a time capsule. Today, underground salt caverns store natural gas, hydrogen, strategic petroleum reserves. Salt's impermeability and plasticity make it ideal for secure storage. As the world transitions to renewable energy, hydrogen storage in salt caverns may become critical. The mineral that preserved ancient fish may safeguard future energy systems. The next time you lift salt between your fingers, remember, you are touching the residue of ancient oceans. You are holding crystallized sunlight and evaporation. You are tasting stellar elements forged before Earth existed. Salt built empires. Salt trapped oil. Salt preserved food. Salt flows beneath continents. Salt moves silently underground. Small crystal. Infinite story. Salt is not just seasoning. Salt is Earth's white memory. This is the geologic lens. True stories beneath the surface.